Hello Internet, welcome. I'm today going to play with ArgoCD. It's a tool that's supposed to automate a lot of continuous deployment tasks on Kubernetes clusters. I'm unfamiliar with it at all, and we will try to play around with it and try to make something work. Let's see. I've pre-configured Minikube cluster locally. It has nothing in it. It's completely fresh. I just typed Minikube start basically, and it's supposed to be already live at this point. And what I'm going to do now is just follow the docs of getting started with ArgoCD and trying to make things work. We will probably spend a lot of time reading the documentation, less time actually running stuff, but we'll see in a minute. So apparently this has not worked. Image was not built for the current Minikube version. To resolve this, you can delete or recreate. Okay, seems like maybe writing Minikube start again was useful in some way. Anyhow, we can now apply this locally to our cluster, which runs a lot of stuff, and I'm really unfamiliar with what are all of the resources that ArgoCD actually deploys into the cluster. But apparently we will try to figure it out together later. The basics is, if you don't know what Kubernetes is, it's basically a container orchestration system that's supposed to be, first of all, really good, but also quite complex. And usually we bolt on top of the bare cluster a lot of tools that help us manage that complexity. Some of that is managing deployments, and this is where ArgoCD should come in and actually help us. Following the getting started guide should help us. So let's actually try to get started. So we have applied this into our cluster. This has created an ArgoCD namespace, and the service and application of ArgoCD will live there. Okay, we could have used apparently a simpler deployment with only the core components installed. I'm pretty sure that using the full thing is the correct one, and follow the instructions to configure a certificate. Interesting. To ensure that the client OS trusts it. Okay, so that's good to know. But let's see what else is going on. So we got kube control configured. We don't have a kube config file. Core DNS can be enabled by micro Kubernetes. Enable DNS. I'm pretty sure I haven't done these requirements and just smashed this in and hope that it would work. I'm pretty sure that Minikube probably has got me covered, but we'll figure out. If we see DNS problems, then we know to come back to this point. So this is the getting started. So we need to install our ArgoCD CLI. So let's do that. Well, that's running in the background. We'll see. Access the ArgoCD API server. By default, the ArgoCD API server is not exposed with an external IP. To access the API server, choose one of the following techniques to expose the CD API server. Service type load balancer, so we can patch service ArgoCD server and expose that externally through the load balancer. That's one way. We can port forward into that. Or, oh, that's it. So we can either port forward or, okay, so port forwarding is a little bit more secure in the sense that we don't need to expose the endpoint to the outside world in a real cluster, which is useful. Like not having a public IP for managing all this stuff is quite useful, and I think I'd go with this one for now. So if we port forward this one and we try to do we need to apply something? No, we don't. So we're gonna now go to localhost here. Let's go to localhost 443. Nothing. HTTPS. Connection refused. Localhost 8080. Okay, privacy error. That's good. Proceed. Let's get stuff deployed. So let's try to figure out how do we move forward here. So because we don't have any API, we don't have any passwords set up, so we don't know how to actually do this. We can also configure this through Ingress apparently. So logging with using the CLI. So ArgoCD admin initial password -n ArgoCD. You should delete the initial admin secret from the CD namespace once you change the password. The secret serves no other purpose than to store the initially generated password in clear and can safely be deleted at any time. It will be recreated on demand by ArgoCD if a new admin password must be regenerated. Okay. So let's just write this and let's see what's going on. So here we have a password. This password must be only used for the first login time. We strongly recommend that you update the password using ArgoCD account update password. Okay, so let's copy that password. Let's update the password into something else. Actually, let's not do that because we're right now in tutorial mode. We're not in the production mode, and this is a Minikube cluster locally. So ArgoCD login. So let's do that. ArgoCD login. Yeah, I probably need to do something like admin and password, right? Or server. ArgoCD server. So this is localhost 8080. Was that right? Yep. The server certificate error TLS failed. Yeah. Signed by an unknown authority. Yes, I know that. Username. Admin. Password. Paste. Successfully logged in. Awesome. So now that we are logged in, we can close this one. What else can we do? Register cluster to deploy apps to. Optional. We probably want to do that. So kubeconfig get contexts -own name. What does that do? So we have, this is not a real thing. We are only on, this actually does not exist. kubectl remove cluster from config. This does not work. Sorry. Kubeconfig delete cluster, then cluster name. And now if we run kubeconfig get context, that does not work at all. Kubectl remove context, delete context, and then paste that again. And then if we rerun the get context name, okay, so this is a little bit better now that we've got everything set up. So ArgoCD cluster add Minikube. In our case, Minikube. Maybe we should have gone with the Docker desktop implementation and remove Minikube altogether. This will create a service account ArgoCD manager on the cluster referenced by context Minikube with full cluster level privileges. Do you want to continue? Yes. Yeah, so basically we're giving super admin access to ArgoCD to manage our full cluster. And it says created bearer token, secret, ArgoCD, RPC error unknown, timeout, connection refused. Yeah, so this is not good. But this is the point where we come back to looking at this and saying we don't have a kubeconfig file, or maybe we do. Oh, I think we do, because, well, yeah, we have a kubeconfig file. Kubeconfig with very long lines. That's quite a funny thing to say about a file, but sure. I'm not going to argue with that thought. Cool. A little bit of humor from the file tool here. By the way, man file, is that a Unix thing or a Mac thing? Is that core utils? I'm diverging, but I'm now core utils file. Yeah, the word, like the name file is just a terrible name for, well, like in retrospect, it's a terrible name for a tool because we use the, like, file is super overloaded, obviously. Anyhow, back to actually doing stuff. So we've got a kube config, its default location is there, core DNS. So do we need to enable DNS in Minikube? So Minikube enable DNS. Ingress DNS. So Minikube start, add-ons, enable ingress DNS. So I think we just want to say enable DNS and not ingress DNS, but enable /help. Can we list the add-ons list? Yeah. So a lot of stuff here. What is enabled? Storage provisioner, default storage class, GCP auth, helm killer. Yeah, so I'm now thinking more about like switching to Docker instead of Minikube, just to make sure everything is kind of the same as the tutorial, but let's continue. So micro Kubernetes. I think this is macOS. So brew install Ubuntu micro Kubernetes install. So I'm pretty sure, is this by Canonical? Wow, I wasn't aware that Canonical were making like their own Kubernetes compliant implementation. That's interesting. Wow, Canonical are like super pervasive with a lot of this thing that they do. Like that they're spread really wide, like in terms of like what kind of software do they actually ship. Anyhow, let's see if we actually want to use this thing. Probably not. Let's try to just write enable DNS. Enable DNS. And it says due to MK add-on enable, not a valid add-on. Then if we say ingress DNS, and then that now worked. And if we go back to cluster add Minikube and we say yes, we're still in the connection refused thing. So let's actually try to take this error and Google it, and then we'll probably see something. Cluster add fails. So we have executed this one. ArgoCD cluster add minikube insecure. Interesting. It is insecure right now. And this is going to work, right? Connection refused. Wait, Argo Manager already exists. That's all right. Updated. Then it says get version, timeout 32 seconds, dial TCP. This one is definitely not port forwarded. So how are we going to enable that? Do we need to enable another thing, maybe? Export ArgoCD. Interesting. Okay, the CLI must be able to communicate with the API server. If it isn't directly accessible, as described in step 3, you can tell the CLI to access it using port forwarding through one of these mechanisms. Either port forward namespace ArgoCD flag to every CLI command, or set ArgoCD opt. And then I think we're just going to export that and not think about it for the rest of this tutorial. And then, yeah, so export this thing. And let's try without the insecure flag. Let's go with yes, and it still refused. And now we got run with insecure, and we say yes, and it still refuses. And then we just need to say something in the lines of, let's run this with also this one. Yes. Oh my god, this is starting to be a little bit annoying. Shall we just expose this through the load balancer? Let's just do that. Patch. Yeah, and now cluster add. Broken pipe. And it says connection refused again. On the same port, but we have newer messages now. So error copying from remote to local connection, TCP, right TCP. With insecure. That's kind of unfortunate. Like, I have installed that. If we copy and run this again, this will probably say like already exists, and it will just unchanged. Yeah, everything is unchanged except for this one configured. Everything else unchanged. And this is probably because we patched the thing and we like defined it with this one. ArgoCD server, is that right? So repo server. Yeah, and let's try to do this again. And let's try to relog in. Where's that relog in? Localhost. Yes. Admin. And that password was somewhere here that we just don't need right now. And ArgoCD cluster add minikube. Please work. Yeah, I'm unhappy with minikube. Let's switch over to Docker. So minikube stop, I think. Yeah. Stopping node minikube, powering off minikube via SSH. And we can, I actually want to even like destroy minikube because we're not going to use that. So minikube delete. Yeah, okay, awesome. So let's try to spin up the Docker Kubernetes thing. So settings, Kubernetes, enable Kubernetes, show system containers. Yes. And apply and restart. And this is now going to actually take a while because Kubernetes is quite heavy. this is, I don't know if we can actually like introspect into the logs of this, but we'll try to see. While this is running in the background, let's see if we can actually like docker ps this and list containers. Nothing here. We have logs, not of a container. I want like system logs. System df info prune events. I wonder if we can actually introspect into this. Docker system events. Since timestamp. Can I just say 940? I need to give it like a full timestamp. That's quite sad. So system events. Let's just let that run. Hopefully this will show something. Yeah. Okay. So image pool. Yeah. Okay. So like this is running in the background, and while this is running, let's try to pretend like the thing is working, and let's just run this here. Let's put that one there. And while this is running, let's read the docs. Just the system events is just like a really crude way to monitor everything here and make sure that we're not missing anything important like failures with the Kubernetes cluster starting on the Docker side. So we're supposed to log in with the CLI. That happened. We're supposed to give ArgoCD cluster management rights basically to everything here. The rules of the manager role can be modified such that it can only has the create, update, patch, and delete privileges to a limited set of namespaces, groups, kinds, etc. However, get, list, watch privileges are required at the cluster scope for ArgoCD to function. Okay, that's fair. And also, like, I'm pretty sure I just want to give ArgoCD like the full permissions because I don't think I will do a better job. And the only like reasoning to not like to limit the amount of permissions it has is just to make it a little bit more secure. But let's be honest, like we're not going to do security right now in this tutorial. But in a real cluster environment, then like the concept of like having the least privilege, giving the least privileges to your components is quite important. Anyhow, create an application from a Git repository. So we have an example repo. We'll open that and visit that in a minute. And we can see kubeconfig set context current namespace ArgoCD. Create the example guestbook application with the following command: ArgoCD app create guestbook. Then it says repo. It points to that repo online, so we don't need to even clone that. And then path guestbook destination server Kubernetes default service. Destination namespace default. Okay. Creating apps via UI. In a browser, we can open the UI, log in by visiting the IP hostname, and then say new app. Guestbook, project default, sync policy, manual. Connect it to the Argo project repo and setting the GitHub repo URL. Leave the revision as head. That's important. I mean, we're probably going to like want to point that to a branch, like the prod branch. Let's call that. Oh, I see Kubernetes is enabled and events have stopped flowing. So we can quit that. We can probably do something like Let's apply our thing to the correct cluster now. So first of all, we need to say kubectl select Docker desktop as default cluster. So config set context Docker desktop. As you can see, having a small GPT in your terminal is quite useful for not remembering all the commands before you enter them. Anyhow, now that we are here, we can run kubectl apply again with kubectl apply. No, let's create the namespace again and apply everything because we need to install that correctly. Unable to connect to the server. Interesting. So how do we go about this? Kubernetes failed to start. That's quite annoying. I mean, what's the point of like using this if it's failing to start? So let's reset the Kubernetes cluster. All stacks and resources. Yes, reset anyway. Kubernetes is restarting. Yeah, so I was apparently a bit too early on being happy that this is finished. I must say that provisioning the cluster on Google seemed more stable, which is not saying a lot because it was. If you watched the previous Kubernetes videos, you saw that it was quite shit. So apparently we can provision the thing either from the UI or from the terminal. Sync deploy application. ArgoCD get app get guestbook. I'm quite surprised that there are no like good logs for the Docker runtime. There is no like Kubernetes thingy here. Maybe kubectl logs cluster info, but there is no cluster yet. That's the problem. Okay, couldn't get API server group list, and it says EOF Kubernetes Docker internal API timeout 32 seconds. I'm quite surprised it's 32. I mean, it's a nice power of 2 number, but why? Because people don't like 30 because it's decimal. Anyhow, failed to start again. Okay, this is getting like ridiculous. Shall we provision a Google cluster? Apparently, let's do that. Let's go with hello GKE, and then it's not a hello GKE, it's a Kubernetes learn provision blah 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 blah. We have a lot of shit here, but we just need to as far as I remember, Terraform apply this, and this will actually create a cluster for us. So let's try to apply that thing, and let's now work with an actual cluster on the internet. This will create, let's just review that quick. So what we will have here is an actual nodes. Yeah, container node pool. Yeah, I think we'll be okay with that. Let's just verify that we actually, node location. So we are going to have one node pool inside the default cluster and one node pool outside of it. And we're not gonna worry about that, it that much. Let's just say yes. We could have actually deployed only with the default node pool with just like one node, but let's actually keep that here because I want to actually, it's good for me to actually like practice deploying it and destroying this cluster. Anyhow, this is now going to actually take a while, but it is going to give us a cluster, hopefully. So yeah, I'm gonna destroy this thing again because I don't want the Kubernetes cluster after all, in locally, which makes me sad because I really hoped that we could actually use that. Anyhow, let's just prune everything here. We can reclaim all this crappy space. No containers. Let's see if we have any leftover volumes. Nothing. Yeah, so Docker is running. And let's close this window. And while this is happening, let's actually Docker system prune and like remove everything. All containers, yes. Destroy everything. Like I don't want this crap here. Reclaimed another like 2 gigabytes of storage. Anyhow, while this is happening, let's keep reading. I'll move my face over here so you'll see the logs. And it will say still creating for quite some time now. It will take, I think, if I recall correctly, about 6 minutes. And let's figure out what can we do while this is happening. So maybe let's keep it this way, and that will go here. As you can see, there is no fancy stuff going on here. It's just me trying to make things work. Okay, so create apps via the UI, open a browser, we can try to add a new app, we give it a name, we have apparently like a project as some kind of good to organize resources and group them together. And let's actually introspect into that Git repository in a minute. Then we can actually deploy that, syncing via CLI. So I think like the magic of ArgoCD is basically that we would not need to like apply resources directly ourselves, and let ArgoCD apply that for us to the cluster. So I'm expecting to have a lot of either YAML files here or a lot of basically YAML Kubernetes template thingies to give ArgoCD to apply. So let's go with Helm guestbook, because I think Helm is like the popular thingy these days. So we have a Helm chart which has a lot of things. So we've got a lot of stuff here. Let's read the notes. Yeah, I think reading YAML templates is going to be painful. That's quite sad. Yeah, okay, so API version 2, name Helm guestbook, a Helm chart for Kubernetes, a chart that can be either an application or a library chart. Application charts are a collection of templates, blah, 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 blah. Yeah, nothing interesting here. Let's try to go back to, I don't know, what do we expect to actually see here? So we've got, let's actually read like the plain YAML, and then we're going to actually use the cool kids, what the cool kids use, which is either JSONet customize or Helm itself. So we've got a service, which is guestbook UI. That's it. Okay. And the deployment itself is going to be history limit, and then, okay, so Kubernetes guestbook demo. So this is where it's actually pulling the image out of. I'm surprised it's actually from Google's container registry and not from Docker Hub. But apparently, yeah, it's here. It's a public image. 200 megabytes. I'm now curious to see like what's actually deployed here. Anyhow, so yeah, okay, it's an application basically, and as we can see, like these YAML files are a simple deployment, and we're going to let ArgoCD deploy that for us, I guess. Yeah, this is probably not connected anymore. So how does that look? So we say ArgoCD app sync guestbook. This command retrieves the manifests from the repository and performs the kubectl apply of the manifests. The guestbook app is now running. You can now view its resource components, logs event, and assessed health status. Syncing via UI. Synced, synchronization, healthy. Okay, let's move on. Well, this is actually a thing. Okay, this guide is for administrator and operator wanting to install and configure ArgoCD for other developers. I'm definitely going to now want to install and configure ArgoCD, so we've done the getting started guide and we can now go over this. So let's try to understand this architecture. Oh, by the way, like that, the cluster seems to be moving forward quite nicely. We have gotten to the point where we are done with the cluster and we're creating the node pool, which means that will be done in a minute, and then we could apply our ArgoCD thing into the new cluster. Okay, moving on. So what does that look like? We are going to merge a PR to Git. We've got a webhook event that sends an API request to our cluster, and we can, when we have ArgoCD, which I'm not sure how how does that listen to like the things that we actually do in Git. Seems like it's not actually connected to that. Anyhow, search application, image Acme search. Search application, image Acme search, v1. Here it's v2. And guestbook application, v1.3. I'm pretty sure this architecture schema is not like the greatest one I've seen. Like, it does not really demonstrate like what's going on here. Let's actually read the text. I think the image is like not doing us any good at this point. Maybe with more text it will become more clear. Anyhow, we've got the API server, which is a gRPC/REST server, apparently. It exposes the API consumed by the web UI, CLI, blah, 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 blah. Application management status, reporting, invoking, application operations, sync, rollback, use the file. Oh, we've got a cluster up. Awesome. So let's try to, I think it's something like a gcloud container cluster get credentials. Yeah, I think that's the one. This is going to authenticate our kubectl with our cluster. So now if we kubectl config get contexts, so now we've got our cluster configured as the default context. Awesome. And like authenticated and everything. So we can now kubectl apply again the ArgoCD thing. So let's back up for a minute just to actually make this work. So we are going back to the installation. Was that? It was in the not in the operator manual. Oh, I see. We need to like go to the get started thing. But apparently, like reading the operator manual should be like probably more informative. Anyhow, we can create a namespace and apply that directly to our cluster. The way I see it, like my goal from like playing with Kubernetes is basically replacing all the custom services that my cloud provider gives me. I just want like the compute and maybe like the cluster, like the control plane management given to me by the cloud provider. but I don't want their pay by millisecond pricing for functions and for paying per event fired from the message queue. That thing I want to be managed by like my own servers at some point. And this, I think, is the plan here. But this is going to take a while because right now I don't know shit about Kubernetes, and this is actually going to be a painful and long process to make things work. As you can see, nothing here goes really smooth. While this is running, we can go back to the overview. So we've got the API server. This will run the kubectl apply basically to the cluster. This has probably like the actual permissions to do that. The repository server is an internal service maintained as a local cache of the Git repository. Holding the application manifests, it's responsible for generating and returning the Kubernetes manifest events with the following inputs: repository URL, revision, tag, branch, blah, 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 and application controller. This is continuously monitors running applications, compares the current live state against the desired target state. Okay, detects out of sync applications and optionally takes corrective action. Okay, that's cool. And we are now fully configured. Let's run the getting started again. So getting started. And we have already installed ArgoCD. Now we definitely don't want to expose that on the internet now that it's an actual public cluster. So let's port forward that. Like what we are missing for us to trust this basically is to have like a certificate authored by someone on the global trust certificate authority. On the like we need a certificate authority to like provide us with an actual certificate. Anyhow, let's now ArgoCD admin initial password. That's on another terminal. This is taking some time. Interesting. Okay, so we are port forwarding. By the way, that means that we can now go back again to localhost 8080, and we are expected to see something that's untrusted, but we know to trust it because like we believe no one has intercepted this traffic while I'm recording this before, like from the previous few seconds that happened. Anyhow, we've got our thingy ready here, and we can now ArgoCD initial password -n. We've got something random that we need to update, so let's actually maybe update that. Yeah, so let's actually update that. So let's run this, and it will say, please give me your old password. Please give me a new password that you want us to set. Okay, so new password. And it says signature invalid. That's because we didn't say insecure. Signature is invalid. Why must we suffer? This is getting quite annoying. Do we want to do something with that? Do we just want to say log in and like not think about it that much? Maybe? Let's not think about it that much. So proceed insecurely? Yes, please. And we need our password from here. So username, admin, password, paste. Login successfully. Awesome. Back to trying to make things work. Update password. Yeah, that's not going to happen apparently. or we can try again to export that and see what's going on, but I'm not, I'm skeptical, basically. Yeah, so let's try that, and again with insecure, just to try to make things work. Enter password currently logged in as, then it says error copying from broken pipe. Oh, well, this seems oddly familiar, like in a very unsatisfying and kind of bad way. If this will be a problem, then I will need to like stop this and actually like bring an expert, or not an expert, but somebody who is like not a complete idiot at this and actually try to make this work. Anyhow, kubectl config-show name. Yeah, we've got this one, and we want to add this name of the cluster because that's the one we're trying to actually manage. So let's try that, and it's ArgoCD cluster add, and let's paste that in and run that. Don't crash. Don't you fucking dare. Up until this point, we've got already, so I'm not happy yet. And this is only taking longer. Added! So we've got a cluster. Amazing. Okay, so let's try to actually make this work. So config, let's try that. And let's run this app thingy, and it says namespace default. And it says again, broken pipe. I'm so goddamn annoyed. Anyhow, let's now go with admin. Let's paste the password, which I don't care that you see because, well, as you understand, this cluster will be destroyed by the time you see this. Anyhow, definitely don't want to save that one. So we've got our guestbook app, and it says missing out of sync. And we can either run this by the CLI or with our with the UI. I can't say words. Let's just run sync and let's see what's going on here. And it says revision. I'd say that synchronized just like that should just work. And if not, then I will find out quite quickly, I guess. If we open that, now we're like within our application and we've got everything working, kind of, maybe. Okay, so like this is actually kind of made of magic. Like what happened here right now is kind of amazing. Like we've got from like just giving basically ArgoCD Git repository with some YAML files to a fully deployed pod in production that might be even exposed to the internet. Let's try to actually see if that is the case, because I'm not sure. By the way, is this like going to serve something? Let's see. Proceed, definitely. Oh, that's my Kubernetes API. That's the Kubernetes server. So that's not interesting that much. But like my guess is that probably I don't want that exposed like completely out to the internet, and I want that to be behind a VPN. But yeah, future me problems with actual production clusters to solve. Yeah, so we have deployed our app, and it is healthy, and it seems like that. And we can now continue with our manual here. So overview, we've been here. we started reading about the application, the thing is here, and we've seen that, and this actually looks good. And now if we actually look at the installation, the multi-tenant installation is the most common way to install ArgoCD. This is the type you typically use. Blah, blah, blah. And users can access ArgoCD via the API server using the web UI, ArgoCD CLI, with just using the ArgoCD login once, and then we can just use that. Non-high availability, not recommended for production use. Yeah, I think multi-tenant is just fine. Let's just let that just be the thing. If it's like the default, then we don't need to think about that. But not recommended. This type of installation is typically used during evaluation period for demonstration and testing. Install YAML standard ArgoCD installs with cluster admin access. Use this manifest set if you plan to use ArgoCD to deploy applications in the same cluster ArgoCD runs in, i.e. Kubernetes service default. It will still be available to deploy external clusters with inputted credentials. Namespace install. Only namespace level privileges. Does not need cluster roles. Okay. Probably not for us. Like I just want to give ArgoCD like the proper access to manage the full cluster, because I want to have multiple namespaces managed by the same cluster. Yeah, by the same ArgoCD deployment. But for larger and larger teams, I would assume that having like a separate deployment pipeline for each team is good, but like I think this is like Google level problems, not mine. Or somewhere like more web scale than like doing like me just basically improvising. High availability. So HA install. So if I recall correctly, the default is using the high availability install thing. I might be wrong, but I think what we have actually applied here is the stable manifest install. So we have not applied the HA install. Interesting. So what would be the difference? This is recommended for production use. This bundle includes the same components, but tuned for high availability and resiliency. The install YAML is the same, but with multiple replicas supported for supported components. And the same thing for high availability namespace install is just the same, but with multiple replicas for supported components. Okay, so not a lot has changed apparently. So if we actually, let's actually open this one, and this is going to be this is a pretty long YAML file. But if we look at the name replicas here and some spaces, so there's a lot of replicas here, and they're all probably like somewhere here. It will actually like say replicas 1. Yeah, basically this thing needs to have like one replica, and probably in some more places it might denote that same thing, but not that interesting. The only thing that's important, that basically the high availability thing is just more replicas of Argo. So if one thing crashes, then it will be available in like another AZ basically. AZ meaning availability zone or region, whatever. Back to actually reading the thing. So now we know that HA install and the normal install are not that different, but it is recommended to have like more than one replica, and like seems fine. But also like try to not like go for the Kubernetes for your blog pattern, which is basically going for the fully highly available sharded multiple cluster, multiple cloud thing before you actually need to have like a lot of stuff. But if your tool manager just recommends that you do the thing, maybe just do that. That might cost you more money. I don't know. Like this probably takes away some compute and some RAM for you out of your hands, and like gives that to a thing that only manages the cluster and does not do like anything for the actual like serving of your traffic. So make your own decisions, but make them kind of informed. Anyhow, the core thing only does the headless thing, and we don't want that because we like the UI. That's nice to have like this thing, like the fact that I can just say sync and press that, and this redeploys the cluster, like redeploys the service. That's really, really nice. Also, this UI is like kind of useful. Like I'm kind of seeing like what's going on here. So we've got like a network, and we've got some stuff going on. We've got our pod, like just the one pod running here, details. I wonder if we can actually see the logs of that. So if we can actually see the logs, this is good. Like I like this. Couldn't reliably determine the server's fully qualified domain name using the IP. Set server name directive globally, or suppress this message. Cool. Like sounds good. Like this is actually useful. We've got pulled, created, started, pulling, scheduled successfully. Like good stuff. I think this is a good thing to have. I don't think I would need the core only installation. This bundle does not include the API server or UI. Installs the lightweight, non-highly available version of each component. Customize. The ArgoCD manifest can also be installed using Customize. It is recommended to include the manifest as a remote resource and apply additional customizations using Customize patches. Okay, so Customize and Helm can both be used instead of like writing our own kubectl apply -f and then a URL like apes. Basically, we can just use like cavemen. Sorry, apes are fine, cavemen less so. Anyhow, yeah, so Helm or Customize, whatever it is that the cool kids use, I think I really heard like better things about Helm, but I heard also terrible things about both. For detailed views regarding ArgoCD's version support policy, please refer to the release process and cadence documentation. I would assume I just use the latest, unless they say we have breaking changes. Don't just run up to the next major version without like actually consulting the docs. Anyhow, moving on. ArgoCD core, we can skip that elegantly because we're not going to use that. Declarative setup. So ArgoCD, applications, projects, and settings can be defined declaratively using Kubernetes manifests. These can be updated using kubectl apply without needing to touch the ArgoCD command line tool. But would we want to do that? Maybe, because we want versioning for everything that we do, and that is quite important. All resources, including applications, app projects, specs, have to be installed in the ArgoCD namespace, by default ArgoCD. Atomic configurations. Sample file. So let's try to look at that and see what's going on here. An example, ArgoCD CM file. So what's the CM standing for? Config map. I see. Yeah, I'm really not like deep in the Kubernetes lingo, so like this is basically you're seeing a true beginner like trying to learn this. So config map. What do we have here? Kind config map, metadata ArgoCD CM, data, URL, externally facing base URL, required when configuring SSO. So ArgoCD demo, Argo proj IO. Interesting. So this is interesting because if we want to access ArgoCD behind SSO, we have to have it. We need, okay, so we can give that like a URL. It needs to probably be behind a CDN, or maybe actually no. This is actually deployed on the cluster. So this is basically, yeah, that's the name of that's the endpoint basically. Okay, never mind. I'm just overthinking stuff. Enables application status badge features. Okay, so specify regex pattern for password. Why do we need this? Google Analytics. What the fuck am I seeing here? No, don't have YAMLs inside YAMLs. Why do that? Why? Dex connector. Do we have like GitHub Actions, something? Okay, there's a lot of stuff here that I just don't know what the hell is going on here. I'm just going to elegantly go back to reading the things here. Resource name, my private repo, Istio Helm repo, private Helm repo. Okay, kind. Sample repository connection details. Okay, so here we have a private Git repository, basically. So my private HTTPS repo. String data, GitHub, ArgoProj, sample apps, password, username. Yeah, so this won't work. Yeah, so this is an example thing, and probably I want like a proper auth integration, maybe, and not like that crap. This seems bad anyway. Okay, so we have an SSH repo. That's sadly seems more like it. Okay, but we have like a lot of basically a lot of examples of how to connect to private repos. Yeah, so that seems somehow better. But anyhow, yeah. I won't use the first example, which somehow like says ignore TLS certificates, which is crazy. And let's move on. So, okay, a lot of like example configurations. I'm pretty sure for each kind of config map secret resource, there's only a single supported resource name as listed in the above table. If you need to merge things, you need to do it before creating them. A note about config map resources. Be sure to annotate your config maps resources with using the label app Kubernetes IO part of ArgoCD. Otherwise, ArgoCD will not be able to use them. Okay, good to know. Applications. The application CRD in Kubernetes resources. Kubernetes resource object representing a deployed application instance in an environment. Okay, I need to read that again. The application CRD is the Kubernetes resource object representing a deployed application instance in an environment. It is defined by two key pieces of information, source and destination. That's the reference of desired state in Git, repository, revision, path, environment. Destination, target, cluster, and namespace. Okay, seems like a cool way to, like a good way to define this resource. So we're saying that's the target, like that's our source, basically like literally the source code or the source repo. And the destination is where do we want to deploy that, which is our own cluster in this example, which is the default service, Kubernetes default service, or we could have had this like in another cluster, as they've said, but we need to authenticate ArgoCD with that cluster somehow and like pass credentials between them. So applications YAML. That is, but by the way, like the fact that my mind is already like moving forward with actually wanting to deploy like actual workloads on this cluster, but we'll leave that for another day. See application YAML for the additional fields. As long as you have completed the first step of getting started, you can apply this kubectl apply application YAML, and ArgoCD will start deploying the guestbook application. So we've already done that, so that's all right. Warning. Without the resource finalizer, ArgoCD project IO finalizer, deleting an application will not delete the resources it manages. To perform this cascading delete, you must add the finalizer. See app deletion. Okay, interesting. So ArgoCD is like by default, it's only updating. It's not destroying resources for us, which is fine because usually you want to destroy things that way. And if we don't want to, like, if we actually want to destroy the like a project, then we can think about that later. So I'm kind of okay with them not finalizing resources by default, but apparently we can just add that to our manifest, and that would work. Anyway, app of apps. You can create an app that creates other apps, which in turn can create other apps, which apparently goes recursively, but by the Yudkowsky recursion law. Yudkowsky law of ultra-finite recursion is that recursion usually are only 3 levels deep. And that's what we see exactly here, which is like, I really like that the fact that I've got that part, but I didn't zoom that in, so you couldn't read that. But basically, Eliezer Yudkowsky said, like, usually in practice, infinite recursions are at most 3 levels deep, and that's like usually the case. Anyhow, going back to actually doing stuff. So cluster bootstrapping, that seems like a good thing to click on. Projects, app project. Okay, so we're basically going like all like around a lot of like different resources. So we've got like Git repositories and a lot of stuff here. I think this is like proper aimed at Git only. I don't think it supports other VCSs. I might be wrong on that, but this is like completely Git oriented. Example of GitHub app. Apparently we can we just like, that seems crazy that we just have here a proper private key. Is that like an actual practice in like Kubernetes files to like put private keys in repos? No. Okay, we need to seal the secrets. Apparently that's a thing. Okay, that seems to be better. Consider using sealed secrets to store encrypted secret definitions as a Kubernetes manifest. Each repository must have a URL, depending on whether it's blah 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 blah. When using secrets, the labels will be removed and will have to be re-added as described here. Sealed secrets as templates for secrets. Okay, so that's a thing apparently I need to read. I think I don't know who Bitnami are, but I've seen a lot of their names all over the place, like regarding like containerized workloads and the deployments. I saw, okay, so I see VMware bought them, so like they're also kind of can be trusted. Sure. Moving on. Yeah, so I'm quite surprised this is like saying you should consider using that. I would not commit like private keys into my GitOps repo because, well, it's like private SSH keys, and you probably want them to be as secure as you can possibly have them if you're sharing these secrets for deployment. Anyhow, moving on. So we've got an example of doing like really crazy stuff, like committing JOTs into Git. repository credentials. Anyhow, okay, so we can define apps basically. Okay, and certificates. Yeah. Sorry, I'm getting like overly shocked by the fact that I see so many credentials here. SSH known host public keys. If you are configuring repositories to use SSH, ArgoCD will need to know their SSH public keys in order for ArgoCD to connect to the. Okay, so we're not just going to use SSH. We're going to use HTTPS if we can help ourselves. How many times? I mean, how many repos are we going to configure? We just need to to use HTTPS basically. Yeah. Configure repositories with proxy, not interesting. Legacy behavior, not interesting. Clusters, GKE, interesting. If we would have used EKS, I would have read the EKS section, but apparently, yeah. Anyhow, GKE cluster secret example using ArgoCD Kubernetes auth workload identity. Seems like a thing I need to read about. Yeah, kind secret. Metadata, my cluster secret. Type opaque string data, my cluster. Config. CR data, base64 encoded certificate. Okay, seems like a thing. And we've got Helm chart repositories. SSO. Seems like a good thing that I would need to know at some point. Manage ArgoCD using ArgoCD. Cool. ArgoCD is able to manage itself since all settings are represented by Kubernetes manifests. This is the suggested way to create a customized based application which uses base ArgoCD methods using from the Argo project ArgoCD and apply required changes on top. So basically we need to fork this one and then just add our own changes, apparently. But I don't think we need to change a lot. Probably the reference implementation is good, maybe. I don't know. I'm sorry that as I said, this is going to be basically me reading a lot of docs, and I don't think this is going to be extremely interesting to watch this through unless you're really you want to see what's going on here. Anyhow, I don't want to read about beta features. Seems not interesting. Ingress configuration. Okay, that's actually interesting. So ArgoCD runs both a gRPC and HTTPS server. Both protocols are exposed by the ArgoCD server service, gRPC and HTTPS. AD redirects to HTTPS. Interesting. Okay, so basically just HTTPS. Ambassador edge stack, automatic TLS termination, and adds routing capabilities. The API should run with TLS disabled. Edit the ArgoCD deployment to add the insecure flag. Oh, okay, so in the case we're using Ambassador, we can have TLS termination on the cluster because Ambassador is doing the TLS termination. We run in insecure mode because we're doing TLS termination on Ambassador. Okay, cool. Contour. Ingress controller, terminate TLS. Seems fine. Okay, so basically, all these manifests here, what they will do is basically they're going to say, we're not going to expose our port, just like we haven't done that here. What we've done is basically we've done port forwarding so we can access it locally right now. But if we'd want to have that in our ArgoCD prod myservice.com and we would want that to be served over HTTPS. What we'd want to do is for like for someone to for some server to do the TLS termination for us with some known certificate, and then not let ArgoCD itself worry about where the traffic is coming from. That just shifts the cryptographic and the trust concerns to some other service. In that, in these examples, it was either Ambassador or Contour, or maybe they will have traffic seems legit, or apparently your own load balancers Google Cloud Load Balancers, which seems to probably do TLS terminations for us. Yeah, seems fine. Okay, so basically there's a lot to deep dive here. I think going over security is a good thing to maybe worry about at some point. So ArgoCD has gone rigorous internal security reviews and pen testing to satisfy PCI compliance. That's good to know. Authentication to ArgoCD is performed exclusively using JOTs. Username and password bearer tokens are not used for authentication. The JOT is obtained, managed in one of the following ways. For the local admin user, username and password is exchanged for a JOT using the API v1 session endpoint. The token is signed and issued to the server and expires after 24 hours. This token used not to expire. CVE 2021. Interesting. When the admin password is updated, all existing JOT tokens are immediately revoked. The password is stored as a bcrypt hash, ArgoCD secret. Okay, cool. For SSO users, the user completes an OAuth login flow with some OIDC. Okay, awesome. Either delegated through the bundled DEX provider or directly to a self-managed OIDC provider. Yeah, I think I will need to get into SSO at some point also. Seems like a thing. I think I these are really good docs. I like them. Authorization performed by iterating the list of group memberships in a user's JOT. Group claims, comparing each group against the roles rules in the RBAC policy. Any match rules permits access to the API request. TLS. All network is performed over TLS using service-to-service communication between the three components. All these three. The ArgoCD API server enforces the use of TLS 2.1.2. With TLS min version 1.2, communication with Redis is performed over plain HTTP by default. Probably okay. Usually it's okay to have internal cluster communication over plain HTTP, because encryption just adds a lot of overhead, and if you trust the components of your system, then that's all right. If you have malicious code running in your cluster, then that might suck, but well, you should be worrying about why you have malicious code running in your cluster. Git and Helm repositories. Managed as standalone service called the repo server. Unauthorized deployment. Since ArgoCD deploys the Kubernetes resources in Git, an attacker with access to a trusted Git repo would be able to affect Kubernetes resources which are deployed. For example, an attacker could update the deployment manifest to deploy a malicious container to running a... Okay, so yeah, basically when you do a Git as infra, this Git repo is super important to not leak and not be unauthorized, not have unauthorized people modifying it. In addition to raw YAML, ArgoCD natively supports two popular Kubernetes config management tools, Helm and Customize. Yeah, so basically just to as we've seen before, nothing fancy, nothing new here. Remote-based Helm chart dependencies. ArgoCD repositories allow list restricts the initial repository, which is cloned. However, both customized and Helm contain features to reference and follow additional repositories. Okay, good to know that like ArgoCD is stricter than what like usually Helm and Customize do. Secrets. Okay, seems good. Kubernetes form before stopped automatically creating tokens for service accounts. Starting ArgoCD. Argo cluster ends. Okay. Cluster RBAC. RBAC, by the way, is a role-based access control, I think, if I recall correctly. Role-based access control. Yeah. Okay. Okay. So a lot of stuff about security. That's really good to know that they care about security. I think maybe that's enough for today. Let's maybe try to understand what do we want to actually do with ArgoCD at this point, because we've got it deployed, so we've got access to an actual ArgoCD thingy. We don't have a certificate right now, so we won't be able to like make this red HTTPS thing green. Like the communication is encrypted, that we don't trust the self-signed certificate because it's, well, self-signed. So we might want to try to deploy another Git app, but I mean, that's not that interesting, because as we've seen, like the actual example of deploying an app is really slim. Like there's nothing in that YAML. If we look at the manifest, it basically says, yeah, go grab some stuff from the ArgoCD app path guest book, and like basically it just deploys the YAMLs here, which are really uninteresting. It has like a Docker container and basically port forwarding for service. So really uninteresting stuff. Like we could deploy another version of that, but that's not that interesting. JSONet, tool detection, private repositories. Yeah, so private repositories, ArgoCD repo add thingy, username and password. So, but like GitHub does not support username and password, not really. So for GitHub, access tokens. Yeah, so that seems to be the way to go here. Basically, or maybe the token itself, instead of using username and password, you might want to use an access token, following the instructions of your Git provider to generate the token. And then we go with TLS certificates for HTTPS repositories. My cert. Using the CLI, that's SSH. Where do we actually use the tokens? Then connect the repository using any non-empty string as a username and the access token as the password. Interesting. I was not aware that's the way to go here. Okay, good to know. Good to know. Okay, so that seems like an easy win. Multiple sources for an application. Wow, I'm quite amazed by the amount of depth that went into these docs. Projects. Logical grouping of applications. Yeah, that seems like a thing. Not interesting that much. Best practices. Let's read that. I think Using a separate Git repository to hold your Kubernetes manifests, keeping the config separate from your application and source code is highly recommended for the following reasons. Provides clean separation of application code and application config. There will be times when you wish to modify just the manifests without triggering an entire CI build. You could also argue that your CI should just be aware of like what directory changed and only like run CI for that, but whatever. Exactly, like when you want to bump the number of replicas, you don't need to like do a full CI thing. Cleaner audit log. That is something that I would also... Is that a cleaner audit log? I mean, if we've got like a git log and git blame for only a single file or only a tree, that I think... Okay, I'm not buying these arguments yet. Your application may be comprised of services built with multiple Git repositories, but it is deployed as a single unit. Oftentimes, microservices applications are comprised of services with different versioning schemas, release lifecycles, e.g. ELK, Kafka, Zookeeper. It may not make sense to store the manifests in one of the source code repositories of a single component. Separation of access. That's the only thing that I think is like actually interesting here, like having permissions and separating that by actually like keeping Git and the deployment out of the way is like and separate in separate Git repositories. That might be a good thing, but also problems of like a really bigger team. If you are automating your CI pipeline, pushing manifest changes to the same Git repository can trigger an infinite loop of build jobs and commit triggers. Having a separate repo to push config changes to prevents this from happening. I mean, if you have an infinite loop, you have an infinite loop. I'm sorry, like... Okay, I only bought like argument number 4 here, which is separation of access. I think all of these can be totally solved by just configuring your CI sanely. I think by separating that, you save yourself like the hour of figuring out how to not run CI when only files in the config changed and not like the source code changed. Or you could also like go read the docs of GitHub Actions and like not worry about it. Leaving room for imperativeness. It may be desired to leave room for imperativeness automation and have not have everything defined in your Git manifests. For example, if you want the number of your deployment replicas to be managed by an autoscaler, there would not be you would not want to track replicas in Git, because that's a good thing, but that's like not a problem of ArgoCD, I believe. Or I mean, it is because like ArgoCD deploys the thing but does not manage the amount of replicas. Okay, fair point. Ensuring manifests at Git revisions are truly immutable. When you're using a templating tool like Helm or Customize, it's possible for manifests to change their meaning from one day to the next. Wow. Okay, that's a good thing to know about like Helm and Customize, that they're not like completely reproducible and like not completely deterministic. This is typically caused by changes made on an upstream Helm repository or Kubernetes base. Ah, I see. So if you're referencing an outside resource and you're just pointing to the latest version, then yeah, you're going to be fucked. For example, so this one is just pointing to the main thing and it's going to change from today to tomorrow. The above customization has a remote base to the head. Having a ref is basically just, I think, would be the best thing to like do here. Okay, cool. The best practices are really good, like most of them. So I bought this argument partially. I bought this argument, and just leaving room for like for auto scaling and stuff like that is just, I think, a good practice for Kubernetes at large and not just for ArgoCD, but sure. Developer guide. Oh, that's like for the actual, like for people who are developing, I think, ArgoCD itself. You probably don't want to be reading this section of the docs if you are going to develop. So yeah, this is not for us. Security considerations. Deprecation notice. Page deprecated. Not going to read that. So yeah, I think we are we've gotten like I've gotten a better grasp of like what ArgoCD does for me and why I would probably want to use that when I use Kubernetes in an actual cluster. I hope you learned something new, and if not, then let me know what you would have liked to see next. And this has been like a completely shallow deep dive into ArgoCD and like doing Kubernetes crap. See you in the next video, where I will talk about something else that I'm not familiar with, and I will try to learn something new. Hope you enjoyed this one, and bye bye for now.